Well, welcome to the final outcome of the course. It's quadratic inequalities. Alright, so quadratic inequalities here, we're going to try to solve problems of like the following. Solve x squared minus 4x minus 5 is less than or equal to 0. Well, there's a few methods we're going to discuss here. And so the first method we're going to try is by graphing the corresponding function. So we're going to graph the function f of x equals x squared minus 4x minus 5. And we'll see where does it dip below 0, because we're looking for less than or equal to 0. Okay, so to graph this, I'll factor this side here. That becomes x minus 5 times x plus 1. So that's f of x. I could say then the two x-intercepts are at x equals 5 and x equals negative 1. Okay, and the vertex then will be halfway between there, so the vertex is going to be at 2, comma, well, I'll plug 2 back in, 4 minus 8 minus 5, oh, so much work. 4 minus 8 is negative 4 minus 5, negative 9. Okay. There's the vertex to negative 9. And so roughly there is my quadratic. Okay? Where is it, though, that we are below 0? Well, right here, right? All of this stuff that's below 0 that I'm highlighting in black, all that is less than 0. Where are we exactly 0? At the intercepts. And so the question was saying, for what x values will we be below or equal to 0, less than or equal to 0? Well, it's for all the x values from negative 1 up to 5 that were below 0. And if we include the equals, that's when we will be at 0 exactly. That's the first method. Okay. Second method is called the number line and test points. Okay, so again, I'm looking at, in factored form, x minus 5, x plus 1 is less than or equal to 0. Okay, so I'm going to take a look at the number line here for all my x values, since I only have x's and no y's. I'll place a point here at negative 1. Okay, and a point here at 5. Okay, now I know that equals is included in the solution. So when I put my points at 5 and negative 1, I fill them in. If it was an inequality like this or this, okay, you put an open dot. Okay, so just as a little aside there. Okay, now I'm going to test some different values here. So we'll test, I don't know, how about negative 2? Okay, we'll test this. So we plug negative 2 in, so that's negative 2 minus 5 times negative 2 plus 1, or you could plug it into the original equation, and that gives us negative 7 times negative 1. That gives us positive 7. Okay? And is positive 7 less than or equal to 0? Well, no. So this is a failed test over here. Okay? Let's test x equals 0 inside this region from minus 1 to 5. If I test x equals 0, I get 0 minus 5, which is minus 5, and 0 plus 1 is 1, and so that gives me negative 5. And is negative 5 less than or equal to 0? Well, yeah, of course. So this was a successful test. This passed. Okay, so in fact, all of this region between these 2 points can be highlighted in this way, so as to signify that all the points between these 2 points pass the test. Finally, you have to try some other point here. Let's try x equals 7, just for fun. You'll get 7 minus 2, or sorry, 7 minus 5, which is 2, times 7 plus 1, which is 8. So 2 times 8, that's 16. Is that less than 0? No, this was a fail over here as well. Okay, and so we reached the exact same conclusion that we reached above. This stuff over here is our solution, and that is -1 less than or equal to x less than or equal to 5. Okay, we're going to try a new method here called Sine Analysis. It's very similar to the method we just used. We're going to check to see if we get a positive, a negative, or a 0 at different values. Okay, so we're going to try to solve this one. I suppose I'll factor first the negative sign, so I'll get negative x squared minus 3x minus 4 is less than 0. And so that's negative. Ooh, what are the factors here? X minus 4x plus 1. Okay? Is less than or equal to 0. Now, when will this expression be exactly 0? When this factor is 0. In other words, when x is positive 4. And it will be 0 when this factor is 0, so when x is -1. What am I going to do now to put these points down? I'm going to put the point down, but this time I'm going to leave the point as an open circle because equals is not included. So I don't want it to be equal to 0. I want it to be less than 0. I want it to be negative. Okay? So the sign test, I just think about any point in a region and check to see if it's positive or negative. So let's say x equals 0. If x equals 0, well, what are my three factors? The first factor is negative, because that's the negative sign right up front there. The second factor, that's 0 minus 4, that's also negative. And the third factor is 0 plus 1 is positive. So I've got a negative times a negative times a positive. Well, what's a negative times a negative times a positive? That's positive. So that region, the expression minus x squared plus 3x plus 4 is positive in that region. Okay, try something else. Let's see, x equals -2. Well, the first factor is definitely negative. The second one, x minus 4, well, that'll be negative. And the third one, x plus 1, well, that'll be -2. So I have a negative times a negative times a negative. Well, that's definitely negative. And finally, over here, you could test some point. Let's say right over here, I'll just kind of play with the scale for fun. Say x equals 100,000. That's in that region, right? It's a long way to the right, but whatever. The first factor is definitely negative. Second factor is now positive. And the third factor is positive. So I've got a negative times a positive, which is negative. So this region's negative over here. So where are my solutions? Well, look at the original equation. We wanted whenever we're less than 0. That is, whenever we're in a negative space. That's over to the right here, or over to the left over here. Those are the solutions. Okay, and so we could state a final conclusion here. The conclusion is x is less than -1 or x is greater than 4. If we're in either of those spaces, we have a solution. And a final example for us today. Solve x squared minus 4x is greater than 10. Okay, this seems straightforward enough, but we're going to encounter one heck of a problem, but that's okay. Let's see, that's x squared minus 4x minus 10 is greater than 0. Okay, factor. Oh, I can't factor. So what do I do? How do I find the values of x such that that expression is equal to 0 so that I can even put them on my number line? Well, how do you solve this when you can't factor? What do you do? Well, you can use the formula. It's the quadratic formula. X is minus b plus or minus the square root of b squared minus 4ac all over 2a. It's an ugly formula, but it works. So that's going to give me minus 4, which is 4, plus or minus the square root of negative 4 squared is 16, minus 4 times a times c, that's minus 40, over 2 times a, which is 2. Wait a minute. What do you notice here? What do you notice about that? This tells me that I have no solution. Why does it tell me that? Because I made a mistake. That should have been plus 40, right? Because it was 4 times a, 4 times negative 4 times 1 times negative 10, which is plus 40. Oh, good. My solution will continue to work. So I end up with x equals 4 plus or minus the square root of 56 over 2. This isn't recording, is it? Okay, so my two solutions here, when x is equal to 0, are the point x equals 4 plus root 56 over 2. And this point over here, x equals 4 minus root 56 over 2. By the way, this can be simplified by factoring out a 2 from root 56. I'll let you do that on your own time. Show me that if you want a little bit of a challenge there. Okay, I've created 3 regions then, and I'm going to say test each of these regions for the sines. Or I guess I can't do sine analysis, so I'll just do a test. Where are these regions? Well, roughly speaking, where is 4 minus root 56? That's 4 minus root 56 divided by 2. That's roughly negative 1.7-ish. And 4 plus root 56 divided by 2 is roughly 5.7-ish. Okay, so those create the borders. Well, then I can test some points. I can test x equals 0. I can test x equals 10. And I'll test over here, I don't know, x equals anything to the left, maybe negative 2. Okay, I'll invite you to do that on your own time. If you test this, x equals 0, you will find that it fails over here, and it succeeds over here. There's a pass and a pass. So our solution then would be x is less than x is less than 4 minus root 56 over 2, or x is greater than 4 plus root 56 over 2. Beautiful. That's a toughie. Okay, and on this final page here, there are 4 examples that are extra problems for you to try. I want you to try these first, maybe before class even starts, so you can bring this into class. Try it out. We'll see how you do, and then we'll be able to move on after that. Thanks very much.